Hey guys, this is the third video for chapter 1 entitled Dimensional Analysis. Now dimensional analysis sounds like a big scary set of words, but really all it is it's a tool that scientists use to solve problems and track units. Units being the most important, tracking the units being the most important thing. In fact, one of my old advisors, and I totally agree with this statement, says that if you can track units, science becomes easy. Okay, chemistry, physics, all those, the basics, at least the general physics and gen chem, they become very easy if you can track the units, because the units are the important part. We all of our data comes from measurements, which come from instruments, which gives us a number with a unit attached. So if we can follow the units, we can solve problems. Now, what do I mean by following the units? Well, in every problem, you're going to be given a couple things. You're going to be given a place to start. You have to be given some place to start. So that's going to be our given unit. Our given unit is where we start. You're also going to be given a question. What do you need? Do you need moles or molecules or meters or inches or whatever? That is your need unit. That's where you have to end. Okay. In a lot of the dimensional analysis I do, it looks kind of like this. I've heard it called railroad tracks. I've heard it called all sorts of things. Where this is my start, this is my given unit, this is what's given to me in the problem, and this right here is my end, is my needed unit. It's what's told in the question. This connector here is a conversion factor. Okay. One thing to keep in mind is that the units directly diagonal from each other have to be identical. Okay, in order for this to work, has to be identical. Okay, so in this question, we've got a person that's 2 meters. What is the that height in inches? 2 meters is our given unit. Inches is our needed unit. Now that seems pretty simple, but as we get more and more complex, it still remains. You have to have a place to start, and you have to be told what to finish at. What grams or whatever. And so what I'd recommend is writing those down, writing those off to the side here. We can say 2 meters is our given unit, okay? And what do we need? We need inches, right? So you can do something like that, and it'll make your life a lot easier. So how do we set this up? Well, again, you set this up I set it up in the little crossroads type thing, little railroad tracks or whatever you want to call them. But you can set it up however you want. Just make sure that your units cancel, that the units diagonal from each other, whether setting it up in this type fashion or the way I do it, those units are identical. They have to be in order to cancel out. As we'll see an example of whenever we don't do that here in just a second. So taking a look at a quick example of setting up a problem with a single conversion factor. Here you can see that we've got 2.5 hours. We want to know minutes, so what do? Well, we have to set up our conversion factor, 60 minutes to an hour, and we set it up like this. Our equality will look like this. 60 minutes equals 1 hour. And anytime we have an equality like that, be it 2.54 centimeters to an inch, or 1.057 quarts to a liter, whatever you want to call it, or whatever unit you're dealing with, those equalities become conversion factors. Just put one over the other. Now, which one goes where? Well, we have to make sure that our units cancel and the units diagonal from each other are identical. Now, we're not always going to be given just a straight conversion factor, right, from start to finish. Sometimes we have to do it more than once, where we have to convert from one thing to another, then to another, then to another. In our previous example, meters to inches, where we had our dude who was 2 meters tall. I don't know. I do, but you may not know how many inches are in a meter, or how many meters are in an inch. So what you can do is convert to centimeters first, then go to meters. All you have to do is to make sure at each point your conversion factor cancels out the unit before it. So like we have here, making sure that the units diagonal from each other, here unit 1 and unit 1, and unit 2 and unit 2, making sure those are identical to ensure that we don't get any crazy units and we don't get anything not canceling out. Now, what do I mean by identical? Well, one of the things that is really important is writing the whole unit. For example, if we have some molecules of carbon dioxide floating around in air, I would say that that is, some number, so we're just going to say some number of molecules of carbon dioxide. Now, why does that matter? Why does that of carbon dioxide count, or why do we have to write that? Well, if we're trying to do some math with this and we're trying to cancel out molecules of carbon dioxide, how do you know if you have the right number if you don't specify what molecules you're talking about? For an example, if we're working with temperature and I say that this gas, this carbon dioxide gas, is at 256 degrees, and I want you to do some math with that. Well, how do you? Is it 256 degrees Celsius, 256 degrees Fahrenheit? They're two very different measurements. So make sure that you always write the full unit so you never get lost, so you never cancel out something that you shouldn't. Let's take a look at an example of using this dimensional analysis thing. We're going to convert, I don't know. I am right now almost 27 years old. So we'll put 27 years. And I want to know how many seconds that is. Okay, I want to know how many seconds that is. So, what do? Do you know how many seconds are in a year? I don't. But I do know something that's smaller than a year, and that's days. Right? I know there's 365.25 days. Maybe I should have made that a bit bigger. Days in 1 year. I still don't know how many seconds are in a day, but I do know that there's 24 hours in a day. And I do know that there's 60 minutes in an hour. And I also know that there's 60 seconds to a minute. Now, what does that get me? Well, if we look diagonal from each other, every single unit cancels out. Days cancels with days, hours cancels with hours, minutes cancels with minutes. And the last one in the top right corner here is what we want. That's seconds. So now that we have our setup, what do? Well, if you set it up like this, what you do is you multiply what's on top and then divide by what's on bottom. Okay? So you multiply everything that's up here. Okay, all this stuff you're going to multiply and then divide by what's down here. Okay, pretty easy stuff. So since we're dividing all by 1, all we have to do is multiply together. Now we're going to get some huge number, 850 something. Now what is our actual answer? Well, let's go through here and look at our significant figures. Now I'm going to pull up the calculator because I've already done this problem. But you see it's 852055200. So how do we know what our actual answer is? Well, let's go back to our problem. If we look here, we have two significant figures for 27 years, two significant figures there. And then look at all of our other stuff. Now our actual answer is going to end up being 800 and looks like 50 million. Yeah, that's what it looks like, 850 million. Now, why is it two significant figures? Because that's what we did. We kept our first two significant figures and rounded the rest. Why is it two significant figures instead of one? Because see, we got a bunch of ones out there. Aren't those one significant figure? Here's 60 in that one significant figure as well. Why don't we care? Well, that's because these numbers are something called exact numbers. Exact numbers have an infinite or an unlimited amount of significant figures. Basically, if it's exactly that number, there's exactly 24 hours in a day, there's exactly 60 minutes in an hour, and if we are counting something, there's exactly that number of something. It's kind of hard to get more exact than 3 oranges if you have 3 oranges in front of you, just as an example. So if it's an exact number, it has an infinite amount of significant figures. And what I always tell students is that when you're converting numbers, you can't change the number of significant figures just by converting from one unit to another. Think about that. If we're taking a measurement, say with a ruler or something like that, we can't get more precise by changing units, right? It'd be kind of cool if you did, because you could just take something and then convert it and have the best measurement ever. So you can't get more precise. You can't change the number of significant figures of your measurement just by changing units. Now, one thing that you always need to do is you need to check the unit cancellation. Okay. In this case, we're converting or trying to convert days to hours. Well, we've got our days to minutes. Sorry. So we've got hours canceling here, but our days don't cancel. And what we end up getting is something that isn't the correct answer. So by writing the units and tracking the units, following what you're doing, making sure all of your units cancel, okay, we can figure out where the problem is. Right here. We got this conversion factor upside down. And so if we flip it over, we can see that we're going to have to flip this guy over too, and we'll get our correct answer. Okay. So always make sure to go back and check your units. Let's do one more example of get rid of this guy here. One more example of dimensional analysis before we call it good. Now I want to do 250 miles, and I want to know how many millimeters that is. Okay, we're going to convert this guy to millimeters. Now, how do I start? Well, my given unit is 250 miles, right? So that's where I'm going to start. Now, I don't know how many millimeters in a mile, so let's go to something else that we can do. Well, I know that there's 5,280 feet in 1 mile. I also know that there's 12 inches in 1 foot. Now, from the last video, you know you have to have one of each type of measurement conversion, or one conversion factor from each type of measurement between English and metric memorized. And so I know that there's 2.54 centimeters in 1 inch. Inches cancel. And then finally, I know that there's 100 centimeters in 1 meter. And then finally, so that's not quite finally, I know that there's 1,000 millimeters in 1 meter as well. I could just as easily say that there is, 10 millimeters in a centimeter. That'd be fine too. But, just since you're starting to do conversions, I always recommend going to the base unit first, and then going back to wherever you need to go. Again, just making sure everything cancels. All units diagonal from each other are identical, so they cancel out, and we end with millimeters. Cool, done. So let's bring up our calculator here, and we do 250 times 5,280 times 12 multiplied by 2.54 divided by 100 times 1,000, right? Just following along. We get this big number here. So what's my actual answer? Because we have, there's a comma, we have 402,000. So how do we do that? Well, what we can do, because we need two significant figures, right? So we're going to keep these first two numbers here and then round off everything else. Well, we're going to have to put this in scientific notation. So it'll be 4.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, and 8. So whenever we write this down, we'll have 4.0 times 10 to the 8 millimeters. Again, two significant figures from our original measurement. All good there. All right, well, the next video will be over density, where we talk a little bit about that formula and all of that jazz. And then there will be one more video after that where we talk about some other problem solving tips and tricks. Otherwise, we're just about done with chapter 1, and I'll see you guys in class.